Uh, Morning, everyone. We're back at our seminar series from the GSFC AI Center of Excellence. Um, Today, we're going to have Ubera Lemu, but before we start with the presentation, just wanted to highlight we don't have any, let's say, announcements at this point. There are a couple of AI-related conferences that are coming through the fall. Some of the deadlines are approaching. I believe they're at the end of August. Um, there are several sessions at EUU related to some of the AI topics from NASA and some of our colleagues. So feel free to, if you didn't add an abstract or didn't do with the deadline, then just feel free to at least join the conference. We have several sessions that are kind of led by NASA and are related to AI and many of the applications. So just to get started, let me just go ahead and present Ubet. Um, Dr. Alemu is an NPP um, working with the Biospheric Sciences Laboratory through the Oak Ridge Associated Universities. His research experiences include land cover and land use analysis, land surface phenology and seasonality dynamics, and food and ecological security using data from active passing microwaves, modern finer, spatial resolution, commercial public, optical remote sensing satellites, reanalysis, climatic and in situ datasets. He earned his PhD in geospatial sciences and engineering from South Dakota State University back in 2017, and a master in science in land resource management back in 2011, and another master in remote sensing and GIS from Ethiopia. He's going to be presenting his work today with Dr. Chris Nye in mapping land cover at very high resolution in the Amhara region of northwest Ethiopia using convolutional neural networks on WorldView Imagery. So Ubed, feel free to take it away.
Okay, yeah, thank you for the introduction. Welcome. Welcome everyone. I'll present you just, I'll go to this presentation, mapping land cover at very high resolution in the Amhara region of northwestern Ethiopia using convolutional neural networks and also the WorldView Imagery. So the Ethiopian economy is heavily dependent on smallholder-oriented agriculture that constitutes more than 90%. And that makes this agricultural system or the economy vulnerable for extreme weather events such as drought and floods. On top of that, slow economic growth and also political instability with fast-growing population produced chronic food insecurity in the region. So particularly our study area is the Amhara region, which is located on the northwestern part of Ethiopia. This region constitutes more than 1/5 of the area of the country, but it's a crop producing area. It constitutes more than 1/3 of the cereal crop production of the country. It has a population of more than 30 million. So it's a highly populated part of Ethiopia, since it has fertile soil and good weather condition in history. And here on the map is the world cover, just as a background, as a reference. And the yellow color here shows the crop areas. So it's the crop areas in Ethiopia are concentrated on that part of the country, including the central parts, central west. The region has two growing seasons in general, but the longer major growing season extends from June to October. We call it current. And there's also a small growing season from March to April. And that small growing season is particularly experienced on the eastern part of the region. The region received a huge amount of rainfall from 5,000 to 2,000 millimeter per year. And the highlands particularly got the highest amount of rainfall. The region has a complex topography, so it has a highly fragmented land cover, land use classes. So particularly crop areas are very fragmented. They are averaging half a hectare, which is a very small area or parcel land. So different land use land cover can occur in shorter distances. So mapping such fragmented land use land cover areas require very high resolution satellite imagery and also robust classification methodology. So the motivation for this study, in addition to the previous introductions that I stated, is Dr. Chris, my supervisor, conducted a land use land cover study on the northwestern part of the Amhara region in Ethiopia. And in that research, the world land cover products that are available today showed a very high discrepancy. So we are motivated to conduct this research on the larger parts of the country, on the Amhara region, just south of the previous Tigray study region. So products from this research can be used for, especially the croplands, the extracted croplands from this product can be used for cropland forecasting, that will be used for planning purposes and also for food security planning issues. So the major dataset we used in this research is the WorldView Imagery from Digital Globe. We produced this data in 2-meter spatial resolution for our purpose. And we processed lots of strip scans from this dataset using a workflow that was developed previously by Dr. Chris and his research group. So we processed this data from 2009 to 2022 for the multi-spec data. But for the PAN, it extends back to 2007 to 2022. And we processed lots of more than 7 terabytes of data for using for this research. So the other data is from Senegal. So the base model, the base CNN model that we used in this research in the Amhara region of Ethiopia is developed in a Senegal project, a separate project again led by Dr. Chris. And in this area, we have collected, in that research, lots of training data were developed using WorldView Imagery. This was the training data were developed semi-automatically using ISO cluster unsupervised classification and also visual inspection. In that research, more than 92 training data sets that has a dimension of 5,000 by 5,000 with 2-meter pixel resolution or spatial resolution were developed. And a base CNN model was developed in that research. So we used this base model for our research in Ethiopia. So as an additional training data set, so for model transfer learning purpose, we have collected few data sets from Ethiopia. So the study area that I'm present now. The training data sets that we collected in this area were developed by the LIFT Ethiopia non-governmental organization. That organization was supported by the British government, and the LIFT stands for Land Investment for Transformation. That project ran from 2013 to 2020. And the purpose for this project was for rural land holding registration or certification, to give land holding certificates for the farmers. That was the aim. this project. So we got data from this project. This project developed this data from, they digitized land parcels on a special mission, 25-meter aerial photos, and they validated this data through field surveys. The corresponding data were collected again through field surveys. And they were able to collect about 9.2 million parcels of land in these years for 9 years. The plan was 14 million land parcels, collect 14 million land parcels, but due to it had a two-phase. It was a two-phase project from 2013 to 2017 and 2018 to 2022. So 5-year span, two-phase project. But they just discontinued their work in 2020 due to political unrest. And they accomplished 66% of their plan. The data that was collected was classified into 9, or it has 9 land cover classes, and we just changed these classes for our purpose into 4 major land cover classes. So we changed them into croplands, tree, shrub, grassland, built-up areas, and the last one is water. The water class is not available in this data, but we developed that in a separate process. And the training data sets, so it was hard to get the training data sets from this project in Ethiopia, but we collected that through personal communication and other means. We collected at least some data sets. And we just selected our data sets from, based on agricultural zone of the study area and also data availability. And most of our data were concentrated on the main crop producing area of the region. So here is the left land parcels overlaid on WorldView Imagery. So the major strengths of this data set include it's very great to retain parcel shapes, and also every parcel in the surveyed area were digitized or delineated. So on this map, the yellow color is cropland, green shrub, and the purple grassland. So it has a perfect alignment with the WorldView Imagery. So weaknesses for this data set include data gaps. There are data gaps for this data. There are also no data values, and also there are some mislabels. The data gaps are mainly on urban areas. So the aim for this project, since the aim for the LIFT Ethiopia project was the rural land area delineation, land parcel delineation, they just left out urban areas. So those areas are follow or no data. Gaps. There are also some shapes that land parcels that didn't have associated attribute data. There are also mislabels. Croplands may be mislabeled as shrubland, that kind of discrepancy. But to cover probably regarding the data gaps, I mentioned the urban areas that have gaps, the settlements, but also land parcel edges were also followed. There was no data. Since the focus was on the land parcels, the edges were left follow. Water bodies also left follow or gaps, and also road networks. For avoiding these discrepancies in our training data set, we did 2 enhancements. The first one was just polygon completion of the available data. topology build-up, and then visual labeling. We labeled those data, the selected training data sets, by overlaying them on WorldView Imagery and also Google Earth Imagery, and labeled them visually. The second enhancement was ISO cluster unsupervised classification. We did ISO cluster unsupervised classification on those selected training areas, data areas. We classed them into 100 classes and then aggregated back into our desired land cover classes. We only focused on built-up and urban trees, since there were hollows for the urban areas, and also since the trees were also mixed in that area, they were not identified by the primary or the original lift land parcel data. So we did that, and then we extracted only our desired layers, labels, and we just merged that with the edited lift parcels. And here on the top left is the original lift dataset. On the right, top right, is a WorldView full color composite imagery. On the left bottom is a ISO cluster classified image, so for a small extracted area actually. And on the right is the enhanced training data that we use it for the CNN land cover classification. So we were able to pick up all the settlements in that data set through ISO cluster classification, which was followed on the primary or on the original lift data set. So this is one training data set, so the whole training data set, I mean full training data set for one specific area. On the left side, on the right is a full color composite of WorldView Imagery. So we were able to enhance the training data sets for our purpose, the classification purpose. And this is again the same training data set that I showed you previously, but here the training data has the field parcels or the shapes without aggregating them by land cover class. And so for the Ethiopian case, for the Amhara region, in addition to the base model from Senegal, we applied ResUnit model for deeper, which is deeper to obtain more features and avoid commission errors. We also apply attention unit model, which is on the bottom right. That includes attention layers to focus learning on the to retain higher context classes. So based on that, we classified our data sets into crop one, tree shrub another, and grass built up, and water just 5 classes. And we also, so this is the workflow for transfer model, or in general, our research. So we collected, we processed top of atmosphere WorldView Imagery for our data, and I mean for our purpose. And we collected, so for the base model from Senegal, labels were made or generated using random training tiles, since there were many tiles there, many training data sets. I'm sorry. So a base model was developed, and then there were training data sets, as I showed you previously, from Ethiopia. So few training data sets for model enhancement. And we use stratified training tiles and bring them into combines them with the Senegal-based model, and we applied attention unit, res unit, and unit models, and then weighted them to get the best model for our land cover classification. We also applied a careful cross-validation for model development as a training strategy, and also we applied on-the-fly geometric augmentation to improve model generalization. We use 512 by 512 tile size for the CNN model development, and we applied veracity and categorical cross entropy loss functions for the model. And finally, these are some sample results from our study area, the Amhara region, and on the left was the classified data, on the right the false color composite corresponding false color composite. We were able to identify and classify our land cover land class, classes there, including very tiny details. For example, just parcel compounds, land parcel, or cropland fences. We were able to identify those kinds of tiny land cover types. And on the, I'm not sure whether you see my mouse cursor, but on this area, this is a semi-terraced mountain top or mountain plateau cropland, and we were able to identify the terraced area or the borders vegetation cover. And this one on the bottom left, bottom right is a corresponding WorldView imagery with smaller size. There is a general pattern of the shrubland, the cropland, but it lacks many details as you see here. And this is the second sample result, again on a mountainous area, mountainous river crop dominated area, but there's also a river gorge associated with shrublands along the river gorges. And so yeah, here is again settlement compound with trees, and we were able to identify those details here too. And this one is the corresponding WorldView imagery from the European Space Agency, and particularly this one lacked many details. So we were able to classify our land classes in a good way. So this is another sample area, land cover product, which is focused on urban areas, semi-urban areas. And the red color here shows the urban areas, the green, the shrublands, yellow croplands. So we were able to pick individual, we can see individual settlements here. You can see on the corresponding, on the right, the corresponding false color imagery, how the details were picked in our classification. And this is a corresponding WorldView, world cover imagery from SCA. And there is a general pattern, but details are not there. And for validation, we validate our data based on, by collecting validation pointers from Google Earth. And the settlement is the shrublands or trees, crops, especially churches in Ethiopia. They have lasted for hundreds, thousands of years. They are very resilient forested areas, churches. So they were, I mean, we pick just validation pointers from these forests and other forest areas actually. And this one is so the whole validation pointers for now that we have. So we were able to produce more than 2,000 validation pointers for this research. And yeah, we will probably add more validation pointers, but yeah, for this one. This is accuracy matrix of so our current products. We were able to classify, so we were able to achieve more than 80% of overall accuracy, particularly trees, croplands, and built-up areas were classified with greater accuracy in our current classification. Water bodies and grasslands have got less accuracy, and there is a reason for that. So the built-up areas, since most areas, I mean, most settlements in the rural areas of Ethiopia, or including small urban areas, since they have highly reflective rooftops, we were able to pick them with greater accuracy. But yeah, clouds and harvested crop stockpiles, they are sometimes confused as built-up area, and therefore there is a less or lower user accuracy for built-up areas. So 84% for the producer accuracy, while the user accuracy for built-up is 67%. So that lesser user accuracy came from these some cloud spotters and also harvested crop stockpiles that were confused as built-up. And for the grassland and water bodies, we have less training samples for these land cover classes, and we are just working on that to add more more training data sets. So as a recap, so we were able to develop a CNN model to process a finer resolution land use land cover classification. And yeah, the model is well fitted for transfer learning. We are able to check that or test that from Senegal to Ethiopia for now. So it has a potential to be used in other similar areas with few additional training data sets. So we were able to process a 2 meter, so high spatial resolution, 2 meter land covered land use maps over a larger area, more than 200,000 square kilometers. Amhara region is a very large area. So we were able to process land cover products with this finer spatial resolution on a larger area. And also the GPU accelerated pipelines to produce maps for the entire study area enable us to process the data with less time. The current issues that we faced include cloud cover in the WorldView imageries, and we plan to apply cloud mask in, I'm sorry. Yeah, I'm sorry. We will apply, we have already a cloud mask algorithm, and we will apply on our on our inputs data sets so that we will get more accurate results. And minimal grass water class, as I stated previously, in our current training data sets, but we already processed those grassland, waterland focused training data sets now, but they are not included in the current result. And fresh croppers mislabeled as trees. So the fresh croppers that looked red in a false color composite image that are sometimes confused as trees in the training data labels that we developed using the ISO cluster, and that has its own impact on the on our current product, and we will take care of that in the future. We are working on that, and especially shrublands, they are broader. For example, a mountainous area is that's non-agricultural. Usually, it's labeled in our original data set as in the training data set as shrubland. While in fact there are sometimes especially grasslands and other covers. So those broader shrublands in our input level that has an issue on the or that brought issues on the final product, and we plan to add more ISO cluster that can take care of those kinds of problems in the future, and we are working on that. And finally, when we will improve accuracy, current accuracies potentially when we aggregate or composite our data sets into the whole study area. And as a next step, we will fine-tune the model using possible fixes that I mentioned previously in the previous slides. Finishing right up publishing results, and we will, as a continuation, we will work on land cover land use class and change analysis using two groups of periods of data from 2009, 2015, and 2016 to 2020. So we will composite our data sets into these two groups of periods for the interest of the temporal resolution issues of the WorldView Imagery, because it's not possible to get the WorldView Imageries in a single year that can cover our broad study area, our current broad study area. Due to that, we will aggregate composite our images into these two groups of periods, and we will do change analysis, and we will publish that result. And we will transfer the models and other products to study area personnel for their purpose, and also for the wider research community. And we plan to apply this models on open source data sets such as Planet, Sentinel, and HLS, so that the wider research community will be able to use our model, and also people in the study area can use that model to routinely map the land cover land use classes, probably in an annual basis or in a seasonal basis. That's all, and thank you very much. Questions?
Much what okay, so it's 11:37. We have enough time for questions if there are any. That was an excellent presentation, Wood, so appreciate your time. Okay, so if you have any questions, feel free to raise your hand or just come off mute. Andre.
Hey, how you doing? I know you said you were using transfer learning. What type of base model were you using again? Were you using ResNet or VGG or
So the base
Impro,
model
yeah.
is sorry,
Go ahead a little bit.
yeah. So the base model is unit chain model. Then yeah, we use other methods in addition to that for the current study area.
okay? Did you happen to try any other base models, um, like a LexusNet or VGG16 or any of the other ones?
No, probably Chris may add. I mean, Jordan may add on this, but just the Unitarian model that was developed in Senegal, it uses, as I said, very diversified data sets spatially and temporally, and a large amount of time and also personnel was invested in that the model development process. So we use that as a base model.
Okay, just curious. Great presentation. Thank you.
Yeah,
Yeah,
just
we
to add
haven't
a quick
considered.
note.
Go ahead, Jordan.
I was gonna say, so we try several backbones, particularly like some of the, not AlexNet, since it's kind of an old architecture that has been there for a long time, but we actually tried backbones as VGE and ResNet, and we're using a couple of ResNet ones for the Res unit backbone, but then the unit-based ones are basically just adding the last 15 layers and just freezing them and then doing some of the fine-tuning on them.
Yeah, I was going to say that a majority of the time in this project is getting the level 1B Maxar data into a point that we can apply the models to it. So considering the amount of time that we had available to us, we haven't tried multiple different input models on the Senegal project side, which I lead. So it's something that we could consider in the future, but programmatically, we're just thinking about the overall amount of time invested into various components of the project. So the validation side of it really eats up a lot of time, as Wabet described, and iterating. So as we're refining these models, that's eating up a lot of time as well. So there's a balancing act here of trying at multiple models as input versus doing downstream activities. And Wobed, if there is another question right now, I did want to bring up the point that another part of your MPP project was to use this map and merge it with HLS to look at the productivity of these individual fields. Did you want to comment on that at all?
Yeah, so this one of the training data sets that I showed is showed clearly the individual land parcels that will be used potentially for classifying land cover, land use class, or to just identify individual land parcels, so an object-based classification based on those open source data sets.
Okay. Any other questions? It's 11:42, so we have enough time.
I have a question, and this is just more level of effort. What would be the level of effort associated with taking this kind of approach, but applying it to a very specific crop, like for example, Ethiopia is really well known for excellent coffee. What would be the level of effort associated with something like that?
I think I didn't hear clearly probably the question. I'm sorry. Would you repeat that?
Sure. I was asking what would be the level of effort associated with making this very, very specific to one crop, such as coffee.
Yeah, there will be a potential, but yeah, for now, just the training data set is so since it's a rural land certification registration, the aim is just picking or registering, mapping the available land parcels, land holdings, and gives them the holders as a booklet for different purposes, for financial, for dispute settlement, something like that. So due to that, individual crop types were not identified in the training data sets. So I'm not exactly sure whether there is another kind of data set that include crop type related to this product. But for now, the data that I have got is just holdings with just general classification, crop, grazing, something like that.
So it sounds like it would be a huge level of effort to make it very specific then. Is that correct?
Yeah, I think, I'm sorry, I didn't clearly hear.
It would be a large effort. So I would say he's already mapped shrubs. If we can spectrally distinguish between shrubs, natural shrubs, and coffee shrubs, that would be a possibility. But having that level of spectral detail, surface reflectance from WorldView 2 and WorldView 3 is a challenge. So essentially what he's processed here is type of atmosphere reflectance. We would need atmospherically corrected data, and unfortunately you can buy that off the shelf from Maxar, but it's extremely expensive. So we've come up with other approaches to produce a surface reflectance like product, but then again you're dealing with snapshots in time, so it would be difficult to have, for example, an annual map over a large area for a particular crop type. In the future, it might be a possibility because Maxar plans on launching the WorldView Legion constellation, where there'll be 30 to 50 centimeter resolution data, multispectral, 8-band collected more frequently. So that might be a possibility, but at this point, the historical record is just too sparse, I would say, to distinguish crop types at this 2-meter scale.
Thank you for that response.
Well, Ben, I
Thank
have
you.
I have another question for you.
Mm-hmm.
Do you think this model is transferable to Tigray?
Sorry?
Do you think the model that you have currently, do you think it's transferable to Tigray?
Yes, no question. Because the landscape, the land cover, land class things, all other things are very similar. And it will be a matter of just adding maybe beer area because there are more beer area in that part using the isocluster things that we already use it. Otherwise, yes.
Yeah, and the reason why I'm bringing it up is there's a lot of political instability in Tigray and widespread famine because of I mean, from what I've seen, which it's not really been reported very well in the news, but we'll bet you have a better idea of how many people have been killed in the conflict and how many people are facing famine because of the conflict. It's something that we could monitor with this model and these data.
Yeah, I'm not sure because there is no any open data of that kind. But it's obvious that lots of people are starving. No question about that. Yeah, but more particularly in that area, but also in the Amhara region too.
Yeah, so big picture, these products are useful for understanding crop index insurance to help food security efforts in the region, as well as understanding, current instabilities in food production. So whenever you combine these maps with HLS, which is Harmonized Landsat Sentinel-2, you can get a better idea of how productive these individual fields are. So that's our big picture long-term goal.
Yeah, sure. Yeah, those index insurances are now in Tigray and also in Amhara region, and yeah, especially the cropland layers that will be very useful for such purposes, and we will make links with such kinds of projectors, people that run these index insurances, so that our products will be usable.
Awesome. Thank you, Chris and Ubed. It's 11:50. Do you have any more questions? Okay. Using the 7 seconds rule. Well, Ubed and Chris, thank you very much for your time. For everyone, this was the seminar for August. We might have an office hour coming soon to talk about transformers, particularly on the vision side of things. And then just be on the lookout for our seminar announcement for September. So appreciate everyone's time and hope you have a great rest of the week. So take care, everyone.
Thank you.
Thanks, Colbert.